Systems are, very simply, units of code that are executed usually once per frame. A system type is defined as a struct that implements the iSystem interface, which is three methods: onCreate, onDestroy, and onUpdate, which all take a system state parameter. If any of these methods are burst compiled, the struct itself must also have the burst compile attribute. Each instance of a system belongs to a world, and generally the entities of a world are only accessed by its own systems. This is not, however, a strict limitation. Systems, monobehaviors, and any code in fact can access the entities of any world. OnCreate is called before the first update. OnDestroy is called when the system instance is removed from its world or the world itself is disposed, and onUpdate is called normally once per frame. The system state parameter of these methods provides access to the system's world and its entity manager. A world's systems are organized into a hierarchy of system groups. Much like a file directory contains any number of files and file directories, each system group contains any number of systems and system groups. Like systems, system groups are themselves updated, and their update behavior can be customized by overriding their onUpdate methods. Their default update behavior, though, is to simply update all the group's children in a pseudo-random sorted order. Every time a child is added or removed from the group, the list of children is resorted. You can control a system group sorting in a way by applying update before and update attributes on its children. Here, for example, assuming my system is in the same group as foo system and bar system, then my system will always be sorted before foo but after bar. The Systems window in the editor shows the hierarchy of systems and system groups in their sorted update order. Three standard system groups are directly updated from the Unity main loop itself: the initialization system group, which is meant to be used for setup work, the simulation system group, which is meant to be used for your core game logic, and the presentation system group, which is used for rendering. Keep in mind that system groups which override onUpdate may update their children selectively or update them more than once in a single frame. The fixed step simulation group, for example, attempts to update its children at a fixed rate per second. So in some frames it updates its children multiple times, but in other frames it doesn't update them at all, much like the fixed update method of a monobehavior. When entering play mode, an automatic bootstrap process will create a default world and populate it with a standard set of systems and system groups, including the initialization, simulation, and presentation system groups. Instances of each system and system group in your project will also be created and added to this default world. By default, they will all be added to the simulation system group, but this can be overridden with the update in group attribute. In this example, my system will be added to the fixed step system group. If for whatever reason you want to disable automatic bootstrapping entirely, just add to your project the scripting define Unity disable automatic system bootstrap. Just understand if you use this, you are then responsible for creating any worlds and creating and adding all system and system group instances. Within a system method, you should use the system state parameter to access the system's world and entity manager, but system state also has its own methods for getting entity queries and getting component type handles, which are used to access the component arrays of chunks. Within a system, you should always use these methods instead of the equivalent entity manager methods because these system state methods register component types with the system. For example, if you get a query for entities with foo and bar components by calling getEntityQuery of the system state, then component types foo and bar will be registered with the system. This would not be the case if you instead called the getEntityQuery method of the entity manager. To understand why it's important for the component types accessed in a system's update to be registered with that system, let's look at one more important feature of system state, the dependency property. Right before a system updates, two things happen. First, the complete method is invoked on the job handle stored in the dependency property of system state. Second, the dependency property is then assigned a handle combining the dependency properties of all other systems which access any of the same components. For example, if component type foo is registered with my system, then the dependency property of all other systems which also have foo registered, those job handles will all be combined into one handle that is assigned to my system's dependency property immediately before each time it updates. The purpose of this behavior is to help us pass the needed job dependencies amongst our systems. But to that end, we must do two things in all of our systems. First, all jobs we schedule in a system update should directly or indirectly depend upon the handle that was assigned to the system's dependency property before the update. Second, before a system update returns, we should assign to the dependency property a job handle that includes all jobs scheduled in that update. As long as we follow these two rules, then every job we schedule will correctly depend upon jobs scheduled in other systems, and the jobs we schedule in our system will be completed at the latest before the next system update. Here, for example, we have a system update which schedules two jobs, both of which depend upon the handle that was assigned to the dependency property before the update, and then the handles of these two jobs are combined into one and assigned to the dependency property before the update returns. This satisfies the expectations of the dependency property. Alternatively, if the second job depends upon the first, then we can assign just the second handle to the dependency property. This still satisfies the expectations because the second job indirectly depends upon the initial value of the dependency property, and the handle we assign to dependency indirectly includes the first job.